The AI cyber capability curve is steepening every quarter. When Anthropic released Claude Mythos Preview in April 2026, it was tempting to treat it as a singular event. A frontier lab built an impressive model, found some bugs, and the cybersecurity community debated whether it was a breakthrough or marketing theater. I covered this in my Mythos video, trying to separate the signal from the noise. 2 weeks later, the UK's AI Security Institute published its evaluation of OpenAI's GPT 5.5, and the signal became impossible to ignore. This is not one model having a good day. It's a capability curve, and it's steepening with every release. And when you layer these evaluations on top of what IO has shown with small open source models, or what MOAC has demonstrated with exploitation timelines, and the structural reality I've been writing about in Vulnapocalypse and the attack surface exponential, a pattern emerges that the industry cannot keep treating as a theoretical. We're already here. So the UK's AI Security Institute runs a suite of 95 narrow cyber tasks across 4 difficulty tiers, built-in capture the flag formats to evaluate vulnerability research, exploitation, and offensive security skills. The centerpiece is something called TLO, the last ones, a 32-step corporate network attack simulation. It's modeled on real enterprise kill chains. It spans 4 subnets and roughly 20 hosts, moving from initial recon through privilege escalation, lateral movement, and the full network takeover. The AISI estimates a human expert would need around 20 hours to complete the full chain. Claude Mythos Preview was the first model to solve TLO end-to-end, completing the full 32-step chain in 3 out of 10 attempts. Across all attempts, Mythos averaged 22 out of 32 steps. For context, Claude Opus 4.6 averaged 16 steps and never completed the chain. On expert-level narrow cyber tasks, which no model could even complete before April 2025, Mythos now succeeds 73% of the time. Then GPT 5.5 arrived. On expert-level tasks, GPT 5.5 achieved an average pass rate of 71.4%, compared to Mythos at 68.6%, GPT 5.4 at 52.4%, and Opus 4.7 at 48.6%. The performance keeps going up. It completed TLO end-to-end in 1 out of 10 attempts and scored 100% on lower difficulty cyber tasks. Here's what matters. 2 frontier models from 2 different labs built on different architectures trained by different teams have both independently demonstrated the ability for fully autonomously execution of multi-stage attack chains, spanning the full kill chain. The capability is not an artifact of a single training run, it's an emergent property of model scale, and every generation that moves the bar higher. And this is not just isolated vulnerability discovery. This is full kill chain execution, lateral movement, vulnerability chaining, which has much stronger implications than a model finding bugs in a code base. Even Anthropic's own red team discussions of Mythos touch on vulnerability chaining. I do want to note the AISI's own caveat. Their evaluation environments lack active defenders and security tooling, and there are no penalties for actions that would trigger alerts. So we cannot say these models would succeed against well-defended systems today. But we also have to acknowledge that most real-world environments are riddled with vulnerabilities, misconfigurations, shelfware security tooling, and teams drowning in alert fatigue. The trajectory is clear, and it's accelerating. If the AISI evaluations were the only data point, you could argue this is a frontier model problem relevant only to the organization spending hundreds of millions of dollars on training compute. IO's research demolishes that argument. In their paper, AI Cybersecurity After Mythos, The Jagged Frontier, IO took the FreeBSD NFS vulnerability that Anthropic highlighted as a flagship Mythos discovery, which was a 17-year-old remote execution bug, and ran it through 8 different models, including open-weight models with as few as 3.6 billion active parameters. Every single one detected the vulnerability. The smallest model, running at 11 cents per million tokens, correctly identified the stack buffer overflow, computed the remaining buffer space, and assessed it as a critical remote code execution potential. IO calls this the jagged frontier. Capability rankings reshuffle completely across different security tasks. The moat is not the model, it's a system you build around it. Their production record speaks for itself. 15 CVEs in OpenSSL, 5 in curl, over 180 externally validated CVEs across 30 plus projects, and they discovered all 12 CVEs in January 2026 OpenSSL's coordinated release. The implication is significant. Vulnerability discovery at scale is no longer gated by access to frontier models. Open-weight models costing pennies per million tokens can surface the same classes of bugs that Mythos found. The barrier to entry for AI-augmented offensive capability is not compute or money. It is orchestration, and orchestration is something anyone can build. So, discovering vulnerabilities is one thing, weaponizing them is another, and the data on exploitation timelines has moved past alarming into structural. The gap between CVE disclosure and working exploit has collapsed from years to minutes. In 2018, median time to exploit sat at 770 71 days. 2021, 84 days. 2023, roughly 6 days. Today, 67% of exploited CVEs in 2026 are 0 days, weaponized before or on the day of public disclosure, up from 16% in 2018. I interviewed Sergey Epp, the creator of the zero-day clock, to dig into this data. Meanwhile, MOAC, mother of all KEVs, demonstrated this in practice using a 5-agent architecture: collector, researcher, builder, exploiter, and a judge. MOAC autonomously exploited 174 out of 178 known exploited vulnerabilities published after the model's knowledge cutoff. It exploited a react-to-shell vulnerability in 21 minutes with no human in the loop. The underlying models are available to anyone with an API key and show autonomous exploitation rates around 80% against real-world KEVs. I sat down with the MOAC creators to discuss what they built in the broader industrialization of exploitation. Sean Heelan built AI agents that generated over 40 working exploits for a single flaw for $50. Yaron Dinkin and Eyal Kraft unleashed AI agent swarms on Windows kernel drivers and found over 100 exploitable vulnerabilities across AMD, Intel, Nvidia, Dell, Lenovo, and IBM in 30 days for $600. That's roughly $4 per bug. When 2/3 of exploited vulnerabilities are weaponized before or on the day of disclosure, the entire model of reactive security, find it, disclose it, patch it, deploy it, has already failed. The exploitation timeline has collapsed below the detection and response timeline. And while AI is compressing the attacker side of the exponential rates, the defender side remains constrained by organizational complexity, legacy architectures, change management processes, and the sheer human bottleneck of triage and remediation. As I covered in my MVD video, the National Vulnerability Database just threw in the towel. NIST moved 29,000 backlog CVEs into a quote-unquote not scheduled category. It enriched 42,000 CVEs in 2025, which was 45% more than any prior year, and still fell behind. CVE submissions grew 263% between 2020 and 2025. Bug bounty programs are hitting the same wall. HackerOne's Internet Bug Bounty Program paused accepting new vulnerability submissions in March 2026 because of a worsening imbalance between discovery volume and remediation capacity. Valid AI vulnerability reports are up 210%. Autonomous agents submitted 560 plus valid reports. 70% of surveyed researchers now use AI tools in their workflow. Discovery has been industrialized, but the human and organizational capacity to triage, prioritize, and remediate has not scaled at all. GitHub is processing 275 million commits per week, on pace for 14 billion this year. First is forecasting 59,000 new CVEs this year, and vulnerability backlogs already number in the hundreds of thousands for large organizations, with remediation rates sitting at roughly 10% per month, and an average of 20 days to deploy a patch. As Simon Goldsmith argued in the context of the vulnapocalypse, the industry is running the wrong race by obsessing over discovery speed when the real bottleneck is remediation capacity. So there's no question that AI has fundamentally transformed the threat model. The capability curve is not flattening. If anything, it's steepening with every model generation and every research paper that shows smaller, cheaper models can replicate what the frontier labs have already demonstrated. The AISI will evaluate the next frontier release and the pass rates will be higher. The TLO completion rates will climb. IO and its open source equivalents will keep demonstrating that you do not need frontier scale compute to find critical bugs. MOAC and its successors will keep compressing exploitation timelines. The MVD will not suddenly scale to 59,000 plus CVEs per year. Bug bounty programs will not solve the remediation bottleneck by pausing submissions. So the real question is whether the industry's defensive infrastructure, its vulnerability management pipelines, its patching cadences, its enrichment databases, and its organizational remediation capacity can evolve fast enough to remain relevant against an adversary that does not sleep, does not context switch, and gets materially better at every quarter. Forma CISA director Jen Easterly published an essay arguing Anthropic's Mythos announcement marks a fundamental inflection point for the cybersecurity profession. AI-driven vulnerability discovery at this capability level changes the economics of attack and defense so profoundly that the traditional model built on perimeter defense, human speed patching, and reactive incident response cannot survive its own current form. The AISI evaluations, IO's research, MOAC's exploitation data, and the MVD's capitulation of all point to the same structural conclusion. An attacker now needs an API key in an afternoon. A defender still needs a quarter and a steering committee. That gap is not closing. It's now the name of the game moving forward. If you have not read the AISI evaluations of Mythos and GPT 5.5, the IO Jagged Frontier paper, and the MOAC research, I will link all of them in the description below. And if you are currently trying to lead a security program figuring out what to do about this, start with my pieces on the vulnapocalypse and the MVD. Check out James Berthotti's work on building an AI-ready vulnerability management program. The frameworks exist. The question is whether we adopt them at the speed the threat demands. Subscribe and I'll see you in the next one.